Well, what I've got here is a foot peg off one of my Morinis. This is actually off the Black 500, and you can see that the thread on the mounting is stripped, and it's got a square head on the end of that fastener, and when the thing's deployed it bottoms out on that square, so we need to duplicate that. So the first thing I've got to do is get this thing apart. As you can see, it's riveted, so we'll get it set up in the vise and I'll drill the staking on the rivet and we'll get this apart. Okay, we're set up in the vise here, and I've had a guess at the size of the rivet as it comes through this this bracket at 5mm. So let's see if we can drill this out. Perfect. And there we go. One square-headed fastener, which I've got to replicate. Now, I'm thinking that the easiest way to replicate this fastener is to take a standard bolt and I'll weld up the head till it's big enough to be turned into the square, and then I'll turn it down to get the thickness. So this is a zinc plated bolt, so I need to clean the zinc off it before welding it, or we'll potentially end up with a case of metal fume fever, which is rather unpleasant, I'm told. So I'm just going to remove the majority of the plating with a file. Okay, well, I've got no filter set up for videoing welding, so it's going to get overwhelmed by the arc, but I've got it with one of the points upwards, and I'm going to build this area up first. I need to build up the width as well, but I'm going to do this one. Well, I must wait the torch to work properly. I need to take this assembly apart and service it. Might lay another bead across the top of that one. Grab some pliers, turn that round. One final pass and then we should have plenty of metal. Well, I've got the multi-size collet chuck on here so that we've got less chance of damaging the threads, and I'm going to take it very careful anyway. We'll see just how hard the MIG weld ended up. Let's go back into high gear and forwards. That's actually turning pretty well. I'm going to sneak down the back of the head with the parting tool and clean up the back face. Then I'll get a thickness measurement and we'll reduce the head to the thickness I want. I just want to make sure everything's going to clear. I might take one more skim off the back. Let's pop that out and have a look. Yeah, I think I'm reasonably happy with that. This is not a precision part or anything. So I'm getting 5.86. So, seeing as this is not a high precision job, if I gently touch off and put in 5.86, I can now work down to the 4mm thickness I want. good enough. And I'll now decide how I want to take this head down to the final square size. The super spacer was still on the table of the milling machine, so I've just decided to use the super spacer to put the flats on here. And I've got my Clarkson style collet chuck on here, and I've shown this before, but new subscribers may not have been back through the old videos. This style of milling cutter is very common in the UK with a screwed shank, and they're cool. I mean, this is a genuine Clarkson, and Clarkson did their auto-lock chucks. So I just screw the end mill into the collet, and you have to rotate the collet so that the tang engages. And if I tighten down the cap, bottom out the cutter, back the cap off slightly, screw the cutter back in, and then all I have to do is hand tighten, and any rotation of the cutter in the collet will actually tighten the collet down. There's a centre in the back, so your cutters always go into a dead length. Okay, we're all set up, ready to go. I'm going to take a cut off alternate sides until they've got a reasonable clean up, and then I'll measure what we've got and work out where we want to go for a final size. I'm going to take this quite easy, as we don't have the best grip on the part possible. Okay, I'm getting 20.41 across those flats, and if I punch in half that, so 10.205, and now that's giving me the distance to the centre, and I'm going to go and measure the original square head. Okay, the original is pretty much 18mm across flats, so I'm looking for a dimension on the DRO of 9mm, twice of which is of course 18. And happy with that. Let's pop him out. It's going to need a bunch of deburring, but one replacement, that's going to do nicely. And these this chuck was hand tightened, and I can hand loosen it. And generally speaking, it would only be a very heavy cut that would tighten it in to the point where I would need to get the tool out to loosen the cap. So I need to make a new pin for this, and I'm getting 27mm, so we probably want 29mm would give us enough to rivet the end over. And it's 5mm diameter. Finished cuts. Okay, we can drill the end for where it's going to be riveted. going to a distance of about 4mm. And I'm going to part it off to give a head a couple of millimeters thick. So I'll just feel for the edges, come back a couple of millimeters. Before I complete the parting off, I'll break the back of that. Of course, the DRO lets us get back into the slot nicely. So there's our pin, just needing a little bit of clean up. So I've got a block of steel. It just happens to be nickel plated because it came out of a an old 10 megabyte Eagle hard disk. And I've got the nicked the vise off the pillar drill. So I've got a centre punch to spread the end of the rivet here. And we're probably going to get some vibration on the camera because that's bench mounted. So that's working nicely, and it bottoms out on that thickness, was why that was important. And we have a decent set of threads, so that can go back on the bike.